Yeah. So 7.3 is also related to this transformer diagram. So yeah, read question 7.3.
The input potential difference causes an alternating current. Explain why there's an alternating current in the output when the transformer is connected to a circuit.
Yeah. What do you think? Why?
Um, I don't really know. Um,
Because the alternating current cause a changing magnetic field around the primary coil and which create a magnetic field that changes the direction. Alternating current means what? It means like this. The current changes its direction. And direct current means what? When it is in one direction like this.
yeah.
So this induces an alternating potential difference. There is positive, negative across the secondary coil, which create, which change the magnetic field directions.
Yeah.
Yeah, because we need changing magnetic field in the core. That's why alternating current is used. Clear? Did you write?
Yeah.
Okay, let's start with 7.4.
Figure 13 shows a large cable supported by two wooden poles. The cable is connected to an electricity supply. There is a force on the cable due to Earth's magnetic field when the current is in direction A to B. What is the direction of this force?
Yeah.
It's think right,
No, it is down. It is
but
down.
it's pointing forward.
That is the direction of
Oh,
magnetic field.
okay, so
If you
down.
use Fleming's left hand rule, then the magnetic field is this, and uh, this is magnetic field, and this is current. So the force will go downward.
Yep. The cable experiences a force of 0.045 newtons due to Earth's magnetic field. Magnetic flux density equals 60, current equals 50. Calculate length of the cable between A and B using physics equation sheet. So you got your force and you have
Hmm.
current. So force, current, force, current, um, force, current, force, force, force on a conductor at right angles carrying current. So the force
Hmm.
equals
Yeah.
magnetic flux density
Yes.
times current times length.
Exactly. Yeah. This formula you have to use. Now we have to find length.
So length is force
Hmm.
divided by mag flux dense times current.
Yes. Exactly.
So the force is 0.045 newtons
Yes.
divided by magnetic flux density,
Yeah.
which
As
is
you can say this.
6.
Hmm. This is 60 micro. So you have to convert from this micro um, into Tesla, which is going to be 60 times 10 raised to power negative 6. Okay, because micro is a smaller unit. You are converting a smaller unit into bigger. So this is 10
So
raised to power negative 6.
60, 60, 10 negative 0, 0.0006
Zero, zero, zero.
6.
Yes. Yeah, this
So
is
zero
stable.
point zero 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 0.00006
Hmm.
times 50,
Yeah, times 50 because current is 50.
2.5 divided by 0.0006 times 50 equals 150.
No, if you
That's right.
times this with
Yes. 60 times 10 to the power of 6. Oh, it's 0. Oh, no.
hmm
0.045 divided by 0.0006 times 50 equals 15.
yeah, the answer is 15. Exactly.
State one assumption you made in your calculation. Um,
And so
as uh,
we assume that the angle between force and the magnetic field is 90 degree.
between force
Hmm.
and and what?
Magnetic field is 90 degree. Angle between force and magnetic field is 90 degree, which make hmm, which make it into one, and that's why we didn't use sine theta and cos theta. Or you, yeah,
Diving bricks sink to the bottom of a swimming pool. Figure 14 shows a diving brick. Swimmers practice driving to the bottom of the swimming pool to pick up the diving brick. Explain why the forces on the brick at the bottom of the pool cause the brick to be stationary. There's force from all the water causing it to stay still, not move. The water,
yeah,
like the weight of all the water.
yeah, there is a downward force which is the weight of the brick, right? Because weight,
Yeah.
the formula for weight is m times g. That means there is a force, gravity, which is downward, and there is the upward force from the water, like you said, okay, which is called up thrust. Okay, so if we do
There's
the sum,
upwards.
yeah, normal reaction
Upwards.
force, normal contact force, there is a contact force. One is upward, which is because of water. One is downward, which is because of the weight.
Yeah.
So the sum of upward force and downward, they are exactly equal. So net force is 0, which keep it stationary.
Okay. When the brick from figure 14 is at the bottom of the pool, the top surface of the brick is 2.5 meters below the surface. The force acting on the top of the surface of the brick due to the weight of the water is 637 newtons gravitational field strength. Calculate density. So Density equals mass divided by volume.
Yeah.
So equals mass divided by volume. And then you have to find. You want to find volume. I think.
But we
Uh,
need volume. We have force. We have area or length. You can see force is there, top surface is there, G is there. We need to calculate density. Mass is given from this figure. Let's go back and check mass. In
the mass. Um,
what is the mass?
mass equals. I think use the volume. So
Okay, we can
what's
find this.
what's the calculation volume again? From in mass. It's
Calculate. Sorry.
the calculation for volume in mass. Do I
For
have to use?
no one.
Yeah.
We have to calculate the density of water in the swimming pool. Okay. So first we find first.
Oh,
Yeah. What we do
so
first, we need to convert this. We need to check the units. We have surface, this is there. So force, first let's find pressure. Force per unit area is pressure, right?
wait. So pressure equals force divided by area.
Yeah, and force is 637.
637 newtons divided by 250 centimeters.
This is okay. We have to, because this is
Oh, wow,
just
2.5.
no, this is one side. I think we need to multiply it. This is in meters, right? We need to convert it into meter square. How? This is, it says the top surface of the brick is 2.50 meter below the surface of water. Is we do we have anything else? We need to find area. Let me look. Yeah. Okay, let's see here. This is 10 centimeter. This is the top surface, right? You see top
Yeah.
surface. We have given one length which is 0.25. Other, how wide it is? 10 centimeter. The height, this is 10 centimeter. So 2.50, and if you find the area, just look at 25 and 10. Even if you forget about that 2 point, what will be the area? 25 times 10, right? Length times width is the area.
Yep, 250.
Yes, but this is in centimeters, so let's convert it into meters. 250 centimeter square, right?
250 centimeters squared. Then you root that.
You will divide it with 1000. Why? Because there is a square. 1 meter is 100 centimeter, but because of square, 100 times 100 will become 10,000. And that's why we are dividing by 10,000. So this will be
Um, 6.25.
0.025, isn't it? We are dividing 250 with 10,000 and 0.025.
I got 6.25.
After dividing 250 with 10,000?
Yeah, 250 squared divided by 10,000 equals
No,
6.25.
250. It's not 250 square. The square is only with centimeter because it is area. Square is only with length.
Oh,
Yeah.
so 250 divided by 10,000. 0.025.
Yes. Now, if you divide these, you will get the pressure.
637 divided by
Mhm.
25. 637 divided by 0.025. 25,480.
Yes, correct. Now, we need to check a density formula which include pressure, which include gravity, which include this length, this depth. This is the depth. Can you check?
Density. Density. Density, pressure. Um, first, first, 1 second.
Okay.
Then, yeah. Pressure due to the column of liquid equals, so pressure
Hmm.
equals height
Okay.
times density
Okay.
times GFS. So to find density, it's pressure divided by height times GFS. So 2,500, no, 2,000, no, 25,480 divided by 2.5 is it 2.5 meters?
Yes,
Uh,
2.5.
2.5 times 9.8.
Yes.
So 254 divided by 2.5 times 9.5. 1,040.
Very good. 1040 kilogram per meter cube. Okay, great. That's correct. So in this one, first we found pressure because we didn't have mass and volume here, right? So if one formula is not fitting, you can check with the other. The other formula had pressure, but we didn't have pressure. So that's why we know the formula for pressure is force per unit area. We calculated area from the figure and force we had. Are you getting? And
Yeah.
from here we got pressure, we plugged it here and everything else we had. So when one formula is not fitting, you need to check for other, and it is not that every time you will just plug one equation and you will get answer, because this is 6 marks. Sometimes you need to use two equation, like here first we used for pressure and then we used for density. Okay.
Yeah.
Okay, next one.
Professional divers are trained in very deep swimming pool. The density of the pool, of the water in this pool is not the same as the density of the water in question 8.2. The diving brick was dropped into the very deep swimming pool. When the brick was at depth 2.5 meters, the force due to the weight on the water on the top surface of the brick was 618 newtons. Determine the force due to the weight of the water on the top surface of the brick using physics equation sheet. So they give you height, they give you
Yeah, you have depth, you have
force,
force or weight.
so height.
And you have, yeah, depth. Okay.
So depth here at the top says time break, figure height, and then you go up force. So force and height. So
Hmm.
it's force.
So what formula?
Jump force to the weight on top surface. Does not force define. Um, force. There's there's moment of a force equals force times distance, or there is pressure equals force normal with the surface area of that surface.
Okay, let's see here. So
There is no
first, hmm, see the
force.
force is pressure times area, but in this case, other formula you will be seeing is this: force is equals to density GHA, height and area, right? Because the density, gravity and area, they are constant. Density,
Wait,
gravity and area.
force equals GHA.
GHA, yeah.
Um,
But this is because these things are, this is not the final form. Do you see any ratio formula here in sheet?
uh,
Okay, let,
no.
okay. So it says that because rho, g and area, these things are constant, so you can just consider what is varying. So first you need to find F and H ratio of force and height. So we need to find force per meter of depth. So let me erase this. So force over height. Force is 618 and height is 2.50, right?
Force over height.
Yeah, this will give you force per meter depth. Like in every meter depth, what is the force? Basically per meter. So if you solve it, you will get 247.2. After this, you will calculate the force at new depth.
247.2. Force at new depth.
Yeah, new depth means at height, the new height which is given as 49.9. As you can look at the figure here, it is given.
Yeah.
So second force is going to be, now you know force per meter depth. If you times it with the new height, you will get the total force. So 247.2 times 49.9. This will give you an answer which is 1233 and 5.28 Newton. So if you have to round it to three significant figure, you will get 12300. Three significant figure means just like this. Okay. So first we calculated force per meter, then we times it with the new height. So this gives us force at the new depth.
How do you know that force per meter depth is that though?
Because this is when the brick was at the depth of this meter. The force due to, because it says here at at this meter depth the force was this, right? That's why I divided it with this length, not the 49.91. Okay.
Okay.
Okay, we are done with this sheet. Or
I
I mean
think
this
so.
page. Yeah. Okay, let's do the other one. Okay. Okay, so I think we can start with 2023 paper.
Give me a second.
Okay.